perfect. Thank you. So we're going to look at a simulation of the Monty Hall problem, and using this problem, we're going to try and gain a better understanding of the law of averages. So I'm quickly going to reiterate what the law of averages is. It says that if a chance experiment is repeated many times independently and under the same conditions, then the proportion of times that an event occurs gets closer to the theoretical probability of an event. As you increase the number of rolls of a die, the proportion of times you see the face with 5 spots gets closer to 1 by 6. Similarly, for instance, if you toss a coin, theoretically, the probability of landing heads is 1 by 2, and the probability of landing tails is also 1 by 2. If I repeat this experiment 10 times, it is possible that I get 5 heads and 5 tails. Actually, these are my expected values. So theoretically, this is what I should be getting. In actual, it's possible that I get 9 heads and 1 tail as well, right? That can also happen. So the law of averages tells us that when you repeat this experiment many, many times, eventually your probability will start approaching the theoretical probability. So if I toss it 10 times, maybe I will get 9 out of 10 heads. But if I toss it 1000 times, I will probably get close to 500 heads. This increases with the number of times you are repeating the experiment. Is that clear? Are there any questions? Okay, great. With that, we have the Monty Hall problem. So, can someone tell me what exactly the Monty Hall problem is? This was discussed in our recent lecture. All right, let's see. Let's look at this over here. It's a very famous problem. Suppose you're on a game show and you're given the choice of three doors. Behind one door is a car, and behind the other two doors, there are goats. You have to pick a door, all right? And then whichever door you pick, the host will the host knows what's behind each of the three doors, by the way. All right. So when you pick one of the doors, the host will open another one of the two doors behind which there will be a goat. So suppose if you're picking one of the three doors, either उस door के पीछे there will be a car or there will be a goat, which leaves the other two doors. जिसमें से एक के पीछे you must have a car or a goat, and then the other one there it is necessary that one of them must have a goat behind them. So the host will open that particular door, which leaves you with two choices. One of these choices is the one that you picked initially, जिसके पीछे either there can be a car or a goat, and then the other choice is the other unopened door, behind which also you can either have the car or the goat. So the question is, should you switch doors right now? Because now the host will ask you if you want to stick with your initial choice or if you want to switch the doors now. All right, so the question is कि इसमें से किस choice में you have the higher chances of landing a car? So would you have a higher chance of winning if you were to switch the door, or would you have a higher chance of winning if you would stick with your door? Can someone answer that for me? Really, people? Okay. So what you actually do is that you do not stick with your choice. You change your choice. When you stick with your choice, you have a 1 by third chance of winning. When you change your choice, when you switch, you have a 2 by 3 chance of winning. So let's try and understand why real quick before we look at this simulation. So anyway, initially I can say कि तीनों doors के पीछे car होने की probability must have been 1 by 3, because I don't know in actual where the car is. So it's 1 by 3 for each door, and then you pick a random one. So the door that you picked, उसके पीछे car होने की probability was 1 by 3, and the remaining two doors, the car being behind either of the two, उसकी probability would have been 2 by 3, which is of course 1 minus 1 by 3. All right, so for those two accumulated, it's 2/3. उन दोनों में से जब एक डोर होस्ट ने खोल दिया एंड जिसके पीछे कार नहीं थी, तो दैट जस्ट लीव्स one of those doors. So the accumulated probability of the car being behind that door will now wind up as 2/3. Hence you should switch. So if you were to repeat this game say 5 or 10 times, and 5 or 10 times, suppose कि आपने इस game को 10 times repeat किया, and all of the 10 times you switched your door. So theoretically, 2/3 of those times, roughly 6 or 7 times out of 10, you should win, right? And 2 to 3 times out of 10 you should lose. But if you're just doing it 10 times, it's possible that 10 out of 10 times you win, or 9 out of 10 times you lose. But if you repeat the same thing 100 or 1,000 times, then your probability will eventually converge to 2/3 and 1/3. So I have something very interesting over here. We're not going to go over this particular piece of code.
एक सवाल था मेरा
Yeah,
कि
go on.
जब जब दरवाजा खोल लिया दूसरा पता चल गया कि उसमें गोट है तो आपका सैंपल साइज रिड्यूस डाउन टू 2 नहीं हो जाता एसेंशियली फिर आपकी दोनों डोर्स की प्रोबेबिलिटी 1/2 नहीं हो जाती क्योंकि अब तक वो कंफर्म पता है कि एक डोर के पीछे गोट है.
Nay, that's not it. Just let me reshare my screen with you guys and let me show you why that is true. Can you see my screen now?
यस.
All right. So suppose that's door 1, that's door 2, and that's door 3. All right. So the probability of the car being behind either of these doors is 1/3 initially. All right. And suppose that the door that you pick is actually this one. So suppose you picked door 3. At this point, can I say कि door 3 के पीछे car होने की probability was 1/3, and the probability of the car being behind either of these two doors? So let's see. So 1 or 2 is going to be 2/3. Is that okay? So I
यस.
built on this intuition basically. अब after this, जब इनमें से एक door open हो गया, so this is what happens. Hold on, let me just copy this figure. Now this timestamp is bothering me. All right, there we go. So now, if the host has opened one of these doors, all right, so उसके पीछे goat निकली, which means कि the probability of it having a car is now 0. All right, and जो आपने door select किया हुआ, that remains 1/3, and this remains x. All right, so this is the math that is actually involved here. 0 or 1 will equal probability of it being behind the door 0 plus the probability of it being behind the door 1. And we know कि 0 or 1 के पीछे होने की probability is 2/3. That does not change. And then we know the probability of it being behind door 1 is 0 now, and this is x. Hence, x equals 2/3. So this is how you can mathematically prove it as well. आपकी distribution change नहीं होती. In fact, initially आपका decision completely uninformed था. अब आपको inform कर दिया गया उन दोनों में से एक के बारे में. That is what influences your probability. I hope that answers your question.
हाँ जी.
Okay, all right, perfect. So let's go back to our notebook. All right. So I have a very interesting simulation over here जिसके code पे हम focus नहीं करेंगे. You can go through it in your own time if that is something that interests you. But essentially, this is what I have. Using this, I can set the number of times I'm repeating the experiment. All right. And let's look at this key that is given to you. Let's look at this legend. So if you stick with your strategy, that is represented using the red line. If you switch your strategy, that is अगर आपने door switch कर लिया, तो that is represented by the blue line. And theoretically, if you stick with your door, we know that the probability of winning should be 1 by 3. And theoretically, we know that if you switch your door, the probability of winning should be 2 by 3. So ये हमने represent किया है इस graph के ऊपर using these dotted lines. When I repeated my experiment 10 times and I plotted it, this is what it looked like. अब plot में मैंने essentially किया ये कि once experiment किया उसके लिए plot किया, then twice experiment जब किया तो I plotted it for that as well, then I repeated it thrice and hence I go up until 10. And clearly I can see कि अभी the distribution seems quite random. It hasn't really converged to my theoretical probabilities. Now when I increase the sample size to 910, this is what happens. See, जब मैंने अपने number of trials increase कर लिए तो it has actually gotten much closer to my theoretical probabilities of 2 by 3 and 1 by 3. Similarly, if I increase this size to 4,000, or if I increase this size all the way to 10,000, and now if I just zoom into this area, so you can actually see that 10K trials ke baad both have been almost exactly 2 by 3 and 1 by 3. And that is how the law of averages works. Are there any questions at this point? All right, so I will leave this for you guys to experiment with as well. For now, we will be moving on to causal DAGs. So in causal directed acyclic graphs, you need to be familiar with three very important structures which have been discussed in class. So I'm going to quickly reiterate all three. Starting with the chain actually. So this is what a chain looks like. A goes to B and then B goes to C, which means A causes B and B causes C, or A indirectly causes C through B. All right? You can leave out the conditioning part right now. That is your chain structure. Then you have your fork structure. Fork structure may you have a confounder present. A confounder is something that has an impact on both the treatment and the outcome. So essentially अगर मैंने A का C पे impact determine करना है तो a fork is a structure जिसका which is causing A as well as C. All right? So this particular structure is called a fork. Then thirdly, you have a collider. A fork, by the way, is a common cause. If I say that B is a fork in this structure, so I mean to say that B is a common cause of both A and C. In a collider, B is a common effect of A and C. So ये difference बहुत important है. A common cause versus a common effect. So in a collider, B is a common effect of A and C. That means A causes B and C causes B as well. Now let's talk about conditioning. Conditioning means you are going to fix the value of a certain variable. So if you do that in a chain, all right, right now we know that A and C are dependent on each other. How are they dependent on each other? Indirectly through B, because like I said, A causes B and B causes C, which means that technically indirectly A is causing C. So hence A and C are dependent right now. If I condition on B, तो मैं इस path को block कर दूंगी between A and C. If I block the path between A and C, then they will become independent. All right. This we actually call conditional independence. So A and C are independent conditioning on B, as is given to you over here. On the other hand, right now, when you look at a fork, this particular structure where B is a common cause of both A and C, so even right now, A and C are dependent on each other. There is a dependency that is introduced because of B. But let me tell you the difference between the dependency that you observe in a fork and the one that you observe in a chain. Chain में आप जो dependency देख रहे हैं that may or may not be causal. It actually is going to be causal since A is causing B and B is causing C, so A is indirectly causing C. So here you can say that there might be some causal association between A and C. जब आप फोर्थ में देखते हैं कि A and C के बीच में कोई association है, so that is it's not possible for you to determine if it's causal or not, because if this association is because of B only, then that means कि this is not causal, that's just an association. It means कि अब जो आप correlation देख रहे हैं वो spurious है. So that was just like our example of when you're trying to determine the impact of smoking on cancer, but then there's a variable that's exercise, and exercise is causing smoking as well as it's causing cancer in some world. Anyway, so in that case, अगर आप smoking और cancer के बीच में कोई correlation observe करें, तो I can say that you were observing that probably because of the confounder in your graph. Hence, it is important to get rid of confounders. That is why we don't condition in a chain, because उधर आपका relationship causal है, so you don't want to block that relationship. But you do condition on a confounder because that confounder is showing you a spurious correlation between the two variables. आप A का C पे true impact नहीं देख सकते unless you condition on the confounder. Are there any questions at this point? All right, so as opposed to that, then you have a collider. In a collider, A and C are already independent. In fact, collider may, if you condition on B, so then you are introducing a dependence between A and C. So a very simple way of putting this is, जब आप chain देखते हैं A, B and C, so A and C के बीच में path is open through B. When you look at a fork, so there is still a path open between A and C. But when you look at a collider, तो अगर एक path पे collider present हो, it means that the path is blocked. That is what we mean by a common effect. When all paths are blocked, we say that the two nodes are independent of each other. So when you condition on a collider, you essentially remove that blockage and you open that path. And that sets our base. Are there any questions at this point before we move on to our practice questions?
वो बात प्लीज एक्सप्लेन कर देंगे बी पे कंडीशन करने से ए और सी में क्यों डिपेंडेंस हो जाएगी?
That's just how a collider works. Collider में आपके पास already independence होती है. So you know आपके पास causal graph में सिर्फ ये तीन structures exist कर सकते हैं. अगर chain exist करे तो वो nodes connected हैं, उनके बीच में dependence है. अगर fork exist करे तो भी उनके बीच में dependence है. But अगर collider exist करता है तो वो nodes independent होते हैं. So बाकी दोनों structures में fork या chain में अगर आप condition करें तो वो dependence खत्म हो जाती है. कोलाइडर में अगर आप कंडीशन करें तो डिपेंडेंस इंट्रोड्यूस हो जाती है. I'm not going to go into the depth of the Bergson's paradox right now, but you're welcome to consult me on it later though, since I'm not sure if we've covered this in class or not. Is there anything else? All right, on that note, let's move on to our first question. So, this is the graph that is given to you. And first, you have to identify all the causal and non-causal paths. So essentially, we will do this on one note here because it's more convenient. All right, so you have to specify all the causal paths and all the non-causal paths between these two. So one very nice way of going about this is just to start specifying all the paths at least. So जो भी paths हैं which are connecting the two nodes, and then a causal path is a particular path जिसमें एक node से जो आपकी path जा रही है उसमें सारे arrows towards the other node ही point कर रहे हैं. Let me just, like, I forgot which two nodes we were doing this for. So between T and E. All right, perfect. So between T and E. So let's list down all paths between T and E. I can see this one path that goes to D and then it goes to E. So I'm gonna write this down. T goes to D and then D goes to E. Let's see what else can we find here. There is this particular path as well. T goes to B and then B to D and then D to E. So let's note down this one as well. T, B, D, and E. And then there is a path that goes like this as well. All right, but is that a causal path or not? No, it's not a causal path. Let me explain why. First, let's write down this path. So at this point, can I say कि in 3 के अलावा there are no other paths between these nodes? I don't think so, but if you can find a path, if anyone can find a path, I can add that. So now, the only difference between a causal and a non-causal path is that causal paths में all your arrows are going in this direction from the treatment towards the effect. Non-causal paths में your arrows may go in different directions as well. Are there any questions at this point? So I am gonna pause here for a few seconds and give you guys some time to think about all the causal and non-causal paths between C and D. Consider it practice. Take a few seconds, try and list them down. Then if someone wants to volunteer a solution, they may. Otherwise, we will move on. Just give me a few seconds. I'm just going to copy this part over here. All right, perfect. Now you can take a few seconds. All right, and I think that that should be enough. Would someone like to tell me the causal paths between C and D?
CTD or CTBD?
Perfect. What about the non-causal paths?
ये ई पे कोलाइडर बन रहा है एक.
Yep, perfect. So that's your only non-causal path. With that, let's move on to our next part then. So this is the first thing. सबसे पहले आपको पता होना चाहिए कि आप कैसे list करेंगे सारी causal और non-causal paths. Because once you are able to list all of these paths, only then can you look at deseparation or backdoor paths. So let's see. Next, we want to list all the deseparated nodes in the given graph without any conditioning. All right. For now, I'm going to just move this slightly here, and I think that that should be all right. Does anyone here know what do I mean when I say that two nodes are deseparated in a causal DAG? Or when are two nodes deseparated? All right, okay. So in order for two nodes in a causal graph to be d-separated, there should be no causal paths between them. All right. Either there should be no direct paths between them with chains or even forks on them. Otherwise, all the paths between them should have colliders on them. So either we need to recall कि अगर एक path पे collide अगर एक path पे chain हो या fork हो तो both of those paths are open. The two nodes are still dependent on each other. एक case में the dependence is causal और एक case में the dependence is usually not causal. All right, this is what we know. And अगर collider present हो path के ऊपर, then in that case it means that they are independent. So d-separated means directionally separated. Essentially हम independence ही check कर रहे हैं. So in order for two nodes to be d-separated, either there should be no path connecting them or all paths connecting them should contain colliders. All right. So it's hard if you have to list all of them initially. So I'm going to start with a few pairs. Let's suppose I want you to first check कि T के साथ कौन से nodes are d-separated. And I have to check every single node. So I have to check B, D, E, and C. Similarly, I have to check against B. अब B के against T को मैंने ऊपर already check कर लिया हुआ है, so I have to just check D, E and C. Then I have to check against D, and D के against I've already checked B and T over here, so I just have to check E and C. Then I have to check for C and E and E के against I only have to check C. So these are all the combination of nodes that I have to check. It may seem like a lengthy procedure, it's not a lot though. Alright, anyway, so let's start with these two, T and B. So first I would want to see कि T and B के बीच में कौन कौन सी paths exist करती हैं. This first path is very evident, it directly connects T and B. Alright, and then what else do I have? I have this one particular path as well where T goes to D, and then, well, D is a collider on this path basically. After this, I can have a path through C maybe. So I have C, then E, then I have D, and eventually I have B. And I think that's it. These are the only three paths between T and B. So जब आपने paths list कर लिए, then you have to check if all of those paths are blocked or not, because the condition was that either all paths should be blocked or any paths that exist should have a collider on them, right? So I'm gonna start from the bottom up actually. When you look at this last path, you see कि इस path के ऊपर C is a fork, right? Because C से arrow बाकी दोनों nodes की तरफ जा रहा है. But then E is a collider, all right? And if you have a collider on a path, it means that the path is blocked. Then let's look at this next one. D is a collider over here, which means that this path is blocked as well. Then if you look at this first one, so that path is not blocked. Obviously that's open because एक direct arrow जा रहा है T से B की तरफ. So can I say that these two nodes are d-separated then? No, see, that's the thing. These nodes are not d-separated because if they were d-separated, those sari paths blocked hoti. Even if I have one open path, it means that they are not directionally separated. They are not independent. All right. So T and B cancels out then. Next, you have to look at T and D. And since I can clearly see that T and D के बीच में भी there is a direct path open, so I know that they can't be d-separated either. Next, I have T and E. So T and E के बीच में, if I just list down the first path that I see, then this is what it looks like. And another path I see through this variable C as well, which is a fork. I'm not gonna list down any further paths because जो मैंने दोनों paths लिखी हैं उसमें से एक पे chain है और एक पे fork है, which means both paths are open, which means they are not deseparated. Then I can look at C and T, and C के बीच में there is a direct path over here as well, which means that they are not deseparated either. By the way, in a path like that, it doesn't really matter कि arrows आपके किस direction में जा रहे हैं. When you're checking for deseparation, that doesn't matter. So this is blocked as well. Now with that, I will give you guys a few seconds to check all of these as well. So अगर आपको एक भी open path मिल जाती है, it means you don't need to check the rest of the paths. So take about 30 to 40 seconds, then let's go over these solutions. So I would recommend कि अगर कोई solution ना भी volunteer करे, so everyone should definitely try this out as that's going to help. All right, I think that should be about enough. Can someone tell me if B and D are D-separated?
नहीं है.
No. Why?
बी और डी से देखते ही एक डायरेक्ट पाथ नजर आता है.
Perfect. What about B and E?
ये भी नहीं है.
Yes, because ये आपके पास एक chain निकल आई between these two. What about B and C?
ये भी नहीं है. ये सी टी बी का पीछे से पाथ नजर आ रहा है.
Absolutely. So ये path है, इस पे chain है सिर्फ. What about D and E?
ये भी डायरेक्ट नजर आ रहा है.
No, there's a direct path. What about D and C?
ये सी टी डी वाला चेन पीछे है.
Perfect. What about E and C?
ये भी डायरेक्ट चेन है.
Perfect. So hence I can say that there are no d-separated nodes in this graph. Are there any questions at this point? All right, with that, let's move on. So अभी तो हमने एक question कर लिया है simple d-separation का. Now let's try and look at conditional d-separation as well. So conditional d-separation just simply means कि अब आप किसी node पे condition करेंगे तो do you have any d-separated nodes or not? Let me just add this over here. I'm gonna move this next graph niche. Actually, next we're gonna be working on this as well. All right. Now you are conditioning on t and that changes everything. So इसको करने का तरीका ये है कि आप उस नोड को सबसे पहले अपने ग्राफ पे एटलीस्ट मार्क कर दें जिस नोड के ऊपर आप कंडीशन कर रहे हैं. So I am just gonna do that. So for me, this means that I have conditioned on the node. All right, अब इस node की value fix हो चुकी है. And with that, I basically have to reevaluate all of these options. So let's see how that changes everything. So सबसे पहले तो what I can do is कि I can get rid of t with all of these nodes, right? Because essentially जब आप t के ऊपर condition कर रहे हैं, तो then you cannot look at whether it is d-separated with any node or not. All right, so you're going to look at all of these other combinations though. Let's begin with the first one, B and D. So Baki, everything goes exactly as usual. You can list all the paths between B and D. All right, so I can see that there is a direct path that goes from B till D, and then there is a particular path that goes from T till B and D. I'm not going to list all the other paths right now because the thing is that even though like okay, so actually since आपने T पे condition कर दिया, so इस path में fork था and we know कि अगर आप fork पे condition करें तो path block हो जाती है and the nodes become independent. So this path is blocked now, but this path is still open, which means B and D are still D-separated. All right, let's look at
जब जिस
something
नोट पे
else.
कंडीशन करते हैं फिर उसके थ्रू जो पाथ्स निकल रहे होते हैं उनको फिर हम इग्नोर करना शुरू कर देते हैं।
Unless it's a collider, क्योंकि जब आप fork पे या chain पे condition करें तो path block हो जाती है, nodes
ठीक है,
independent हो जाते हैं. But जब आप collider के ऊपर condition करें तो वो path already block जो हुई होती है वो open हो जाती है.
ठीक है।
So this is the key difference to remember. So अब हम B and E को भी देख लेते हैं. I think one path goes like this through T. Initially, इस path के ऊपर C is acting as a fork, T is acting as a chain, which means that this path was open. But जब मैंने T के ऊपर condition किया, तो मैंने इस path को block कर दिया. Now it's no longer open. But we have to evaluate the rest of the paths as well, though. So I actually see this particular path which remains open anyway, which means that these two are not d-separated. So then we can look at B and C. And let's see. So B and C के बीच में there was this one particular path where you had a chain, which is now blocked, but let's list down all the rest of our paths as well. So then you had B goes to D, and then D के आगे you have E, and then C. Let me see quickly if I'm missing something as well. Yeah. So goes from T till D, and then E, and then C. So I think these are all the paths. I don't think that I have missed anything. So सबसे पहले हम इन सब paths में T को cross out कर देते हैं. This first path contains E as a collider, which means this path is blocked. Sorry, the second path. And then the first path contained T as a chain, so the path was initially open, but now it is blocked since I have conditioned on T. And similarly, if you look at this particular path, तो इसमें भी आपने T के ऊपर condition कर दिया, which means that the path is blocked. Either way, it doesn't matter because there is a particular collider on your path as well. So your path is going to be blocked either way. So
ये
there
लास्ट
might,
पाथ
yeah,
कैसे मैप आउट होता है ये प्लीज शो कर देंगे आप? ये
yes,
आखिरी वाला।
just a second. So आखिरी वाले के अंदर I can say कि E जो था it was a collider, right? Which means ये path initially भी blocked ही थी. See, E is a collider, right? Since D से
जी
arrow E पे
वो
जा
मुझे
रहा है and
समझ आ
C
गए
से E पे जा रहा है. Yeah.
मैं बस कह रहा था कि वो पीछे ये टी वाला टी से जो कर रहे थे वो नहीं मुझे समझ आया। आप लाइक आउटलाइन करके बता सकती हैं डायग्राम पे
अच्छा जो
ये
path
पाथ?
हमने draw out की है, I understand your concern. Look, T से arrow B पे जा रहा है and then T से arrow D पे जा रहा है and then D से arrow E पे जाता है and then that is how we wound up at C. Does that make sense? And you just like state all of those arrows.
अच्छा आ, अच्छा बी से टी से डी से ई.
Absolutely, because although the arrows are in all sort of directions, but the point is that it is a valid path, right? पाथ तो एग्जिस्ट
अच्छा.
करता है. सो अब उस पाथ के ऊपर ई वॉज अ कोलाइडर विच मीन्स कि ये पाथ ऑलरेडी ब्लॉक्ड था और कंडीशन हमने किया टी के ऊपर. सो द क्वेश्चन इज डज दैट ओपन द पाथ और नॉट, एंड द आंसर इज दैट नो इट डज नॉट ओपन द पाथ, क्योंकि कोलाइडर वाला पाथ सिर्फ तब ओपन होता है जब आप कोलाइडर के ऊपर कंडीशन करें. So this path will remain blocked. इसमें T पे condition आप करते या ना करते, this path would have remained blocked. So I can say that all three paths are blocked, aren't they?
लेकिन जो जो आपने अब पार्ट ट्रेस किया आखिरी वाला उसके अंदर तो टी एज अ फोर्क एक्ट कर रहा है. आपने बी से टी से गई या बी से डी तो नहीं गई इस वाले पाथ के अंदर.
The last path? नहीं,
हाँ
मैं
जी.
इसमें T के through D पे गई हूँ. And
जी.
T was a fork and T पे मैंने condition कर दिया. अगर मैं
जी.
fork पे condition करूँ तो path block हो जाता है, right?
जी.
But मेरा path
जी.
पहले से भी blocked ही था, so it doesn't really matter.
अच्छा.
So my path will remain blocked either way. Which means that, like, since all the paths are blocked, the B and C are going to be de-separated. All right?
अच्छा.
It means कि अगर आप T पे condition कर दें तो B and C are de-separated now because all the paths between them are blocked. So ये बड़ी important एक चीज है, this is very important, कि when you are trying to determine whether two nodes are de-separated, so if they are de-separated, then you have to list down every single path and make sure कि वो सारी paths blocked हैं. But if you're trying to determine that they are not de-separated, तो आपको कोई एक path भी मिल जाए जो open है, तो you don't really need to look at any of the other paths then. I hope that makes sense.
अगर ये टी
Anyway.
वाला पाथ ब्लॉक ना करते तो तब भी आखिरी वाली रूट जो थी वो ब्लॉक्ड ही थी ना ई की वजह से, ई वाले ग्लाइडर की वजह से.
एब्सोल्युटली यस. लेकिन जो पहली वाली पाथ थी वो टी की वजह से अब ब्लॉक हो गई थी, वो पहले नहीं ब्लॉक थी, जो इसेंशियली ये वाली पाथ थी.
अच्छा,
ओके.
आई हैव अ क्वेश्चन.
यस, गो अहेड.
अच्छा, ई लास्ट पार्ट में आपने बताया ई कोलाइडर है, लेकिन डी भी तो कोलाइडर है उसमें.
होल्ड ऑन अ सेकंड. अच्छा, अब आप मुझे बताएं, डी कोलाइडर है? नहीं, डी इज नॉट अ कोलाइडर, डी तो चेन है इसमें, लुक. डी से दोनों एरोज आगे जा रहे हैं. डी इज पार्ट ऑफ अ चेन. एक कोलाइडर का स्ट्रक्चर ऐसा होता है, एक चेन का स्ट्रक्चर ऐसा होता है, एंड एक फोर्क का स्ट्रक्चर ऐसा होता है. डज दैट मेक सेंस?
यस, इट में.
Okay, anything else, guys? Okay, we're going to be moving on from this. I'm going to leave this working over here for now. And now I will give you guys a few seconds to check all of these remaining nodes as well. Just remember कि हमने T पे condition किया हुआ है. All right, I think that should be about enough. So I'm going to get rid of this as well. Can someone tell me whether D and E are D-separated now or not?
D and E are not D separated.
No, because there's still a direct path right over here. What about D and C?
ये है डी सेपरेटेड क्योंकि
Yes,
इस कोलाइडर के अलावा टी ही था जिसके थ्रू सी डी को करा था
absolutely.
इंटरैक्ट.
Perfect. So एक ये पाथ थी जिसमें E was a collider, so ये पाथ already blocked थी. उसके अलावा this was the only path जिसको हमने block कर दिया by conditioning on T. So yes, D and C are now D-separated. What about E and C?
ये भी डायरेक्ट पाथ बन रहा है.
Yeah, absolutely. So they are not D-separated. So this is the answer that we were looking for. When you condition on node T, so B and D and C are the two pairs that are D-separated now. Are there any questions at this point?
अच्छा, मेरा वो कॉजल पाथ जो निकाले थे उससे मुतल्लिक एक क्वेश्चन था मेरा.
Yes, go on.
अच्छा, एक ये जो साइक्लिक सा पाथ बन रहा है, क्या ये भी एक वैलिड पाथ होगा जो कंसीडर होगा जिसको हम लिखेंगे ये
Oh, you know what?
टी से.
इस ग्राफ में कोई भी cyclic path नहीं बन सकता because it is an acyclic graph.
मतलब
Will
नहीं,
you
मतलब
tell
कि
me?
साइक्लिक से मेरा ये मतलब नहीं कि सारे एरोज एक दूसरे में, मतलब कि ये टी से ई से, ये सी से डी से डी से ई वाला, ये.
This
हाँ
path,
जी.
right?
हाँ जी. इसको हम मेंशन करेंगे एज अ नॉन कॉजल पाथ.
अच्छा हमने पाथ डिटरमिन करने थे कॉजल एंड नॉन कॉजल बिटवीन टी एंड डी ये तो बिटवीन सी एंड डी है
ओ अच्छा, तो हम स्टार्टिंग पॉइंट सिर्फ टी और ई ले सकते हैं
या
कॉजल पाथ
एब्सोल्युटली
स्पेसिफाइड हो.
सो कॉजल एंड नॉन कॉजल पाथ्स होते हैं हमेशा बिटवीन टू नोड्स दैट्स माय बैड आई इरेज्ड दैट एक्चुअली सो बिटवीन टी एंड ई
ठीक है.
सो
तो
अगर
मैंने
कोई
जो
और
भी.
दो नोड्स होंगे अगर सी एंड डी होते तो दिस वुड हैव बीन अ वैलिड कॉजल पाथ एक्चुअली
ठीक है.
ओके इज देयर एनीथिंग एल्स गाइस एनीवन एल्स Okay, all right. With that, let's move on. This is also called the law of large numbers, right? Abu Bakr, I'm so sorry. I saw this very late. Nature law of large numbers hai, it is, I think it is slightly different from this. But that is something I was planning to touch in tomorrow's session as well. So let me actually get back to you on that. Okay, with that, let's continue. Can you guys still hear me?
यस.
Yeah, my PC seems to be stuck. Give me a few seconds. Like, मेरे tabs ही नहीं switch हो रहे. Okay, I think, yeah, that's fine now. Oh, yeah, there's also one more very important part which I was saving for the end. Then we'll move on to the next question. So, what variables should we condition on in order to find the true total effect of T on E? So, hold on, if I can just quickly specify over here. Because ये भी फिर confusion होगी. So this essentially means कि मैंने condition कर दिया t पे given that t. Okay, now what variables should we condition on in order to find the true total effect of t on E? Alright, so अब आपने t का impact determine करना है on E and you want to find the minimum number of nodes that you need to condition on in order to do so. So ये वाली चीज deseparation से थोड़ी सी different है. Now we're essentially hunting for all backdoor paths. Can someone define a backdoor path? Okay, so a backdoor path is essentially any path जिसके ऊपर fork exist करता हो, in very simple words. In actual, it's a path where an arrow is going into the treatment and it's also going into the outcome. So essentially, if this was your treatment and this was your outcome, so ये backdoor path थी. ये backdoor path इसीलिए है because ये वाला जो arrow है it goes into T and then an arrow along the same path goes into O as well. These paths are caused because of forks being present. And one thing that we understood about forks at the beginning, which I'm quickly going to reiterate as well, is that when you have so for instance when you have a chain, so A goes to B, B goes to C, so A and B are dependent on each other, but that dependence is going to be causal, so you don't need to condition on B. At the same time, if B was acting as a fork instead of a chain, so you will observe, and a fork means ke like it was the common cause of both A and C. So in that case, you will observe an association between A and C, but that association is probably not causal. That is something that you're just observing that because of a confounder being present along that path. So fork में जो variable होता है जो common आपका cause है उसको हम confounder भी कहते हैं, and these confounders often show us spurious correlations, and it is important to condition on confounders because they show us spurious correlations, because they cause backdoor paths. We need to condition on them in order to determine the true impact of one variable on another, just like we looked at in one of our probability examples in the last session, I believe. Just may you had the size of kidney stones and then you were determining the course of treatment. So anyway, it's essential to condition on confounders. At the same time, the third structure that we are aware of is a collider, and collider wala path already blocked होता है, so you don't have to do anything with that path. Alright, so essentially अब हम T and E के बीच में सारे paths देखेंगे, and we will look at all the backdoor paths, and then you have to block all the backdoor paths. So let's start listing those. So I think T and E के बीच में सबसे पहले I observe a path over here. Oh, actually the coolest thing is that I already wrote down all the causal and non-causal paths between these two, so I can just use this. Like I don't need to write that again. All right. So even I can get rid of this as well. These are all the paths between T and E. So अब आपने देखना है कि इनमें से कोई path backdoor path है या नहीं. So I'll give you guys a few seconds to think about it. Look at the paths that are open, the paths that are blocked, and the paths that are backdoor paths, and see if you can identify any backdoor paths between these two nodes. Okay, I think that should be about enough. Can someone tell me if the first path is a backdoor path? So guys, I'm going to reiterate this. It should be very simple. आपने जो भी paths list किए हैं, उन paths में आपने देखना है if there are any paths where the arrow goes into the treatment as well as into the outcome. And there is only one such path, that is the third one. So I'm going to say that this is a backdoor path. The other two are not backdoor paths because I have no confounders on those paths. एंड इन सिंपल वर्ड्स इन पाथ्स में सारे एरोज जो हैं वो इस तरह नहीं है कि कोई एरो टी की तरफ जा रहा है और एरो ई की तरफ भी जा रहा है. So I just look at the backdoor paths and then I look at all the confounders and I have to block them. And there is just one confounder, that is C. It means that in order to determine the true total effect of T on E, you need to condition on C only. Are there any questions at this point? Okay, perfect. With that, let's move on to our next graph and let me see what we are required to do over here. So this is the question that is given to you. First, you have to identify all the causal and non-causal paths from X till Y. So I have this graph here with me already. So essentially, this is very straightforward. I will give you guys a few seconds to think about this while I start listing the paths down anyway. So these are the only two paths between these two nodes. Is the first path causal or is it non-causal? It's non-causal. What about the second path? Is that causal or is it non-causal? So in this particular example, both the paths connecting x and y are non-causal in fact. And x and y के बीच में there exists no causal path. This is the first thing that we have been able to determine. No causal path, just two non-causal paths. So let's see, what are we required to do next? Oh, I can just copy this particular thing because we're doing exactly this. So once again, you have to list all the d-separated nodes in the given graph without any conditioning. So essentially that means maybe you can start with A and then you can check A against X, B, D, C, and Y. Similarly, next you can check for X, and since we've already checked X against A, so we're going to check B, D, C, and Y. Next you have D, and D को आप check करेंगे against C and Y. Oh, hold on, am I missing something? Oh, I forgot to start with B here actually. So you can check for B first, and then you can check that against D, C, and Y, and then you can check for D. And D will be checked against C and Y, and then C and Y will be checked against each other. All right, I'm going to increase my pace over here, and you can feel free to try out the next one in your own time as well. So let's start with A and X. There is a direct path between A and X, so I know that they are not d-separated. Then I have A and B, and A and B के बीच में there is a path using a chain through X, so they are not d-separated either. Then I have A and D, and a long chain goes from A till D as well. A till X, X till B, and then B till D. So they are not d-separated either. After that I have A and C. So A and C के बीच में एक path आपकी ये बनती है from A till X, and then through B it goes till C. On this path B is a collider, which means that this path is blocked. There is only one other path between A and C, which is through Y. On this path Y is a collider, so this path is blocked as well. Hence, we only had two paths between A and C, both of which were blocked, so I can say that A and C are d-separated. Next, you have A and Y, and I can clearly see a path over here, so they are not d-separated. All right, moving on, you have X and B. X and B are directly connected. Then you have X and D. They are connected through B via a chain structure, so they're not d-separated. Okay, then you have X and C. अब X and C के बीच में you have two possible paths. This is the first one. It goes through B. So if you condition, sorry, we're not conditioning on B right now. And since we're not conditioning on B, so we know that this is a blocked path. Then you have another path as well, जिसमें A is a fork, but Y is a collider. And if there is any collider present on a path, so it automatically blocks that path as well. That means that X and C are d-separated. All paths between them are blocked. Then you have X and Y. So X and Y को एक ये path connect कर रही है through A, where A is a fork. A fork doesn't block a path, it causes dependence between the two nodes. So I don't need to check the other path. I can say that they are not d-separated. Then I have B and D, which are directly connected. Then I have B and C, which are also directly connected to each other. Then I have B and Y, which are connected through a fork where C is the fork. Thus, this path is open as well. Then I have D and C, which are connected through a chain. And then I have D and Y. D and Y are connected through the same fork, that is C, which means this path is open. Lastly, you have C and Y, which are directly connected to each other. So इस question का answer होगा, you have two pairs of nodes, A and C, and then you have X and C. These two pairs of nodes are d-separated in the graph without any conditioning. So are there any questions at this point? Okay, next we are going to condition on B. So I'm just going to copy this from here. So I'm going to take this exact thing and all right, let's get rid of B everywhere first. And then let's check. So I don't need to check any of these any longer, and I don't need to check any of this anymore. Which leaves me with these nodes only. All right, so with that, let's get started. I'm just going to highlight the node that we have conditioned on. All right. And now let's start checking. So first you have A and X. A and X are still directly connected. A and D were initially connected through B. So ये एक path था that went from B, but you have blocked B, so now this path is blocked. This other path went through Y, where Y was a collider, so this path is already blocked. And आपने B पे condition कर लिया, but आप B पे ना भी condition करते तो भी this path was blocked, which means that these two nodes are d-separated now because only one path was open and now we have blocked that path. Similarly, you have A and C. A and C के first path पे, the one that goes through Y. Y is a collider, so that is blocked. And this other path goes to X, then B, and then it goes to C, where B was a collider. So B was a collider on this particular path. लेकिन जब आपने B पे condition किया तो ये path open हो गई. And now, since a path is open between these two nodes, it means that they are no longer deseparated. So it's also possible कि पहले two nodes were deseparated, but जब आपने किसी collider वाली path पे condition कर दिया collider पे, तो now they don't remain deseparated anymore. Next, you have A and Y, which are still directly connected. Then you have X and D. So X and D had only one path between them. It was a chain and it went through B. Now you have blocked that path. It means that they are going to be deseparated. The other path goes through B as well, essentially. अगर आप यहाँ से path draw करें, तो that first goes to B as well. And either way, you have blocked B. And on the other path, you have a collider on Y as well. So next you have X and C. X and C ke liye we still have this particular path which contains a collider on Y. So this path is blocked. And then this other path was through B, where B was a collider. And now we have opened this path by conditioning on B, which means that X and C are no longer deseparated either. What about X and Y? So X and Y ke beech mein to there's a path through A where A is a fork, so they cannot be deseparated. Then you have D and C. They were also essentially connected through B, only through a chain. So आपने B को block कर दिया, you block this path, now they are deseparated. Next you have D and Y, and basically D is connected to everyone through B somehow. And D and Y के साथ भी ऐसा ही है. You have blocked this path, then you have this other path as well, which you have also blocked. So they are deseparated now. And lastly, you have C and Y, which are directly connected, so they're not deseparated. Hence, the answer that you are looking for is you have four such pairs now. You have A and D, and you have X and D, you have D and C, and you have D and Y. Are there any questions at this point? So we have our last question over here. अब आपने X का Y के ऊपर total impact measure करना है. And you want to figure out which nodes you have to condition on. I'm just gonna edit this, X on Y. So essentially you have already listed all the paths between X and Y. So I'm just gonna copy and use these. And now we just have to check ke in paths ke upar if like either of them is a backdoor path. And let me tell you guys what, because of these arrows and these arrows, both of these are backdoor paths. All right, that is the first thing that we have established. Both are backdoor paths. I'm gonna specify this over here. And in a backdoor path, you find the confounder and you condition on it.
ये
इसमें
एक्स से बी वाला पाथ जो है वो कोलाइडर वाला पाथ नहीं है, ये जो सेकंड वाला है.
एंड कोलाइडर कौन सा नोड है उसमें?
बी जो है, अगर आप
नो नो,
एक्स से
बी
वाई
इज
वाला
कोलाइडर. आप इस
एक्स के
पाथ की
अंदर
बात कर रहे हैं ना, दिस पाथ.
ये इसके अंदर
या तो इसके अंदर तो देखें बी इज अ चेन बेसिकली. सी दोनों एरोज एक ही साइड पे जा रहे हैं.
लेकिन इसके अंदर ये असल में जो चेन बन रही है वो एक्स से बी से सी से वाई अगर देखें तो एक्स से भी एरो बी के अंदर जा रहा है, सी के अंदर भी एरो बी के अंदर जा रहा है. तो
नहीं, बट बी
ये
से एरो
ये वा,
एक्स की तरफ जा रहा है. सो अगर मैं इसमें इस चीज को आइसोलेट कर लूं तो ये चेन है बेसिकली, इजंट इट?
बी से एरो कैसे एक्स में जा रहा है डायग्राम के अंदर?
Oh, you are right. I did list it wrong. You're absolutely right. B से arrow X के अंदर नहीं जा रहा, X से arrow B के अंदर जा रहा. Yeah, so you're right. B is a collider then. Let me edit this over here as well. Yeah, you're right. इसमें B is a collider and इसमें C is a fork though. So far I know one important thing. I know कि मुझे A पे तो condition करना ही पड़ेगा because A is a confounder for me right now. So I found uh, that also means one other important thing. It means that this is the only backdoor path, right? Because the other path is no longer a backdoor path. Backdoor path की तो condition ही ये होती है ना कि an arrow should go into the treatment as well as the outcome. So then I no longer need to look at this path, even though इस path के ऊपर भी C is a confounder, right? But I don't need to condition on C. The reason being कि ये path already blocked थी because of a collider. So आप सिर्फ backdoor paths को देखते हैं. You only look at backdoor paths when you're trying to determine the total impact of one variable on another, and then you look at any confounders along those paths and then you condition on them. Since we only have one backdoor path and x is the only confounder on that path, so then our solution is that you will condition only on A. Is that okay? Guys, are there
अच्छा,
any questions at this point? Yes, go
बैकडोर
on.
जो फोर्क बैकडोर कंसिडर होता है वो सिर्फ वो वाला फोर्क होता है जो ट्रीटमेंट और आउटकम को डायरेक्टली कनेक्ट करे।
बैकडोर पाथ वो कंसिडर होता है पाथ आपका बेशक जितना मर्जी लंबा हो फॉर इंस्टेंस लाइक फॉरगेट अबाउट द ग्राफ सपोज t is my treatment and y is my outcome, okay? So a b c d e and then y ये बैकडोर पाथ है इट डजेंट मैटर टू मी के बीच में कितने नोड्स हैं आई जस्ट लुक एट द फर्स्ट एरो एंड द लास्ट एरो अगर फर्स्ट एरो ट्रीटमेंट के अंदर जा रहा है और लास्ट एरो आउटकम की तरफ जा रहा है तो इट्स अ बैकडोर पाथ आई होप दैट आंसर्स योर क्वेश्चन
अगर अगर फर्स्ट एरो ट्रीटमेंट के अंदर जा रहा है और लास्ट एरो ट्रीटमेंट आउटकम के अंदर, ठीक है, समझ आया।
एब्सोल्युटली सो बैकडोर पाथ वही पाथ होती है जिसमें ट्रीटमेंट के अंदर भी एरो जा रहा हो और आउटकम के अंदर भी एरो जा रहा हो जब इस तरह की पाथ एग्जिस्ट करे तो इसका मतलब होता है कि देयर मस्ट बी अ कंफाउंडर और समथिंग अलोंग दैट पाथ देन यू हैव टू फाइंड द कंफाउंडर एंड यू हैव टू कंडीशन ऑन इट
और जो पीछे वाला जो क्वेश्चन में था, उसके अंदर ट्रीटमेंट के अंदर से बी की तरफ एरो जा रहा था, इसलिए वो बैकडोर कंसिडर नहीं हो सकता। ये वाला जो एक्स से, क्योंकि
यस
एक्स से बी एरो
एब्सोल्युटली
जा
सो
रहा था, इसलिए
या
बैकडोर नहीं।
सो इसमें अगर
ठीक
आप
है,
फर्स्ट और लास्ट एरो देखें तो एक्स से भी एरो बाहर ही जा रहे हैं एक्स के अंदर एरो नहीं आ रहा दैट्स व्हाई इट्स
ठीक
नॉट
है।
अ बैकडोर पाथ सो इनिशियली सिंस मैंने एरो गलत डाला हुआ था इसीलिए आई लेबल्ड इट अ बैकडोर पाथ in actual it's not. All right, guys. Any other questions at this point?
Yes, I have a question.
Yes, go on.
अभी जो आपने लास्ट में एक पाथ बनाया था वो
This one?
हाँ जी, यस, इसमें देयर इज अ बैक डोर फ्रॉम टी टू आई, बट
Yes, there
इसमें
is.
इसमें कोफाउंडर क्या होगा?
आप मुझे बताएं इसमें कंफाउंडर क्या होगा?
सी,
I mean, think about it. What? नहीं, because
आई
C
गेस
से
सी,
दोनों arrows इस तरह जा
वो
रहे हैं. C
हाँ
तो इसमें
हाँ
chain है.
हाँ सी चेन है, आई थिंक
So
इट
essentially,
विल बी
it's
इट
yeah.
विल बी ई, आई गेस, नो,
No, because
ए
E is
ए
also a
ए,
chain. Yeah, perfect. You got it right. So it's gonna be A because A से arrow दोनों की तरफ जा रहा है. और जो हमारे पास कंफाउंडर है वो एग्जैक्टली वो चीज होती है जिससे एरो दोनों की तरफ जा रहा हो दैट्स अ कंफाउंडर इट्स अ कॉमन कॉज ऑफ टू वेरिएबल्स इज देयर एनीथिंग एल्स
बस एक कोर्स से रिलेटेड, इस टॉपिक से रिलेटेड नहीं है, बट लाइक एक रिक्वेस्ट थी कि जो कल जो प्रोजेक्ट की डेडलाइन है वो सुबह 9 बजे पे सेट की हुई है, तो अगर
यस
वो प्लीज रात 12 बजे तक अगर हो सकती है पुश।